With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi everyone, let's take a question. So here the question is that among the phosphorus, sulfur, chlorine and fluorine, okay, most and the least negative electron gain enthalpy will be respectively. So here if we talk about the electron gain enthalpy, this is the representation for our electron gain enthalpy. Okay, so suppose here we have one neutral gaseous atom, it accepts an electron and it forms the anion. Okay, and when it forms the anion, the energy released to accept that electron is our electron gain enthalpy, because here we have the neutral and here it forms the anion by accepting an electron. So here it is the energy released when a neutral gaseous atom accepts an extra electron to form the gaseous anion. So that is our electron gain enthalpy, right? So now here we are given with the phosphorus, sulfur, chlorine and the fluorine, right? So here when we will have, let's write the group numbers. Okay, these elements belong to, here we have second period. Okay, then it will be easy to know us that what will be the sequence. Okay, here 15, 16, 17. Now we know that the phosphorus belongs to third period, sulfur to third period, and the fluorine to second, and the chlorine to the third period. Okay, and these both belongs to the same group. So now what happens is, as we move from left to right across a period, okay, as we move in this way, electron gain enthalpy, that is our this value. Okay, electron gain enthalpy, what happens is it becomes more and more negative. It becomes more and more negative. Okay, but as we move, okay, while within the group from top to bottom, okay, if we move from top to bottom, it is less and less negative. Okay, why this happens is because as we move from left to right, we are attaining the stable configuration, right? Like if we talk about the phosphorus, if we talk about phosphorus, then in the case of phosphorus, what will be our configuration? It is our 15th. It is the element with the atomic number 15, right? So if we talk about the configuration for the phosphorus, then what it will be? Okay, so here if we write down the configuration, so phosphorus, for the phosphorus it is our 3s2 3p3, and for the sulfur it will be 3s2 3p4. Okay, for the fluorine and for the chlorine, okay, these both belong to the same group. These both belongs to the same group. For the fluorine we have is 2s2 2p5. Okay, and for the chlorine we have 2s2, sorry, 3s2 3p5. Okay, because it belongs to the third period, it is 3s2 3p5. So here if we see, the fluorine and chlorine needs only one electron for the stable configuration. It needs two, it needs three, because the p orbital have the six electrons. Okay, so here it means that now the phosphorus will have the least, right? Phosphorus will have the least, because as we move from left to right, the electron gain enthalpy becomes more and more negative. So here it means that for most and least. Okay, so these two are incorrect. Our answer will be from these two, right? Our answer will be from these two. Now we know the answer is our option number one, because the least negative is the second one. So here least is for the phosphorus, that is sure. Now we want to know why the chlorine have the most electron gain enthalpy. As we have already told that as we move from top to bottom, the electron gain enthalpy becomes less and less negative. Okay, then why for chlorine have the more electronegative, more and more negative than the fluorine? Okay, so here what happens is, when we have the F, fluorine, it has the smaller 2p orbital. It have the smaller 2p orbital. So the addition of an electron to the smaller 2p orbital, it leads to the inter-electronic repulsion. It leads to the electronic repulsion. Okay, but if we talk about the chlorine, in the case of the chlorine we have the large 3p orbital. We have the large 3p orbital. Okay, so it So there was no problem in adding the electron to the chlorine as compared to fluorine, because there we will have the inter-electronic repulsion. So that's why chlorine has the most electron gain enthalpy, most negative electron gain enthalpy. Okay, so here that's why our answer is option number 1. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.